what I'm going to tell you now, since I've already discussed about the lobes, the surfaces, the poles, and the borders, I'm sure you must have understood all this, right? So, what are the demarcating landmarks for these poles that I made mention? You see, for you to be able to say, this is frontal lobe, this is temporal lobe, this is occipital lobe, this is parietal, there must be a demarcating point that will demarcate one lobe of another. Are you clear? Good. Each of the cerebral hemispheres in either surfaces, whether in the lateral surface, inferior or on the medial side, each of these surfaces, they have a lot of bumps. Bumps. You understand? And depressions, or we call them hills and valleys. You get my point? So we have hills and valleys. The hills are what we call gyri. Some they call them gyri. You get it? So gyri is for plural. Singular is called gyros or gyros. You understand? The valley or the depression is what is called Silicas. Plural, Silicai or Silicai. You get my point? So it's either way. So Silicas is just the depression in between the adjacent gyri or gyri. Are you clear? So plural of Silicas is Silicai or Silicai. So we have seen that all these are present on either surfaces of the cerebral hemispheres. And the more of these gyri in you, probably the more intelligent you may be. An intelligent person has a lot of bombs in his own brain. You get it? Those idiots among you, those who don't understand anything, the stupid guys, they don't have as many as the gyri as the intelligent guys. Are you clear? Each of this is a convolution. So the more convoluted your brain is, the more brilliant, more smarter, more intelligent you may be. Are you clear? Good. So each of these Silicas or groove, it differs in length. You may have one Silicas that is short, and you may have one that is smaller. So when you have a very long Silicas going deep inside, that is what you call a fissure. Fissure. F-I-S-S-U-R-E. Fissure. But a shorter groove or Silicas, a shorter groove or depression is what we call a Silicas. So Silicas is a shorter depression or shorter groove, while fissure is a deeper groove or deeper depression. Are you clear? Yes. Good. So now we've seen Silicas and gyros. It is this silici or fissures that demarcates one lobe of another lobe. There are two most important, prominent fissures or silici on the superior lateral surface of the cerebral hemisphere. That's what we call central Silicas. This central Silicas demarcates the frontal lobe of parietal lobe. Are you clear? So I said that there is one very long depression, a Silicas, that demarcates frontal lobe of parietal lobe. because it is located virtually in the center. When you divide the cerebral hemisphere into two halves like this, anterior half and posterior half, the central sulcus is in the midline, and that is why it is called central sulcus. Are you clear? So this central sulcus demarcates frontal lobe of parietal lobe. There is also a very long sulcus or groove that is lying virtually horizontally in between the frontal lobe and the temporal lobe. And this sulcus or groove here is what is called lateral sulcus. Lateral what? Lateral sulcus, but in some textbook, they call it lateral fissure of Cerebral. Lateral what? Lateral fissure of Cerebral. Because Cerebral was the one that discovered that fissure, it was named after him. You get it? So we have lateral fissure or sulcus of Cerebral demarcating frontal lobe of the temporal lobe, while the central sulcus demarcates frontal lobe of the parietal lobe. Now, what demarcates the parietal lobe of the occipital lobe? There is a small sulcus here. Very small. It's not as prominent as long as this central and the lateral. This is what we call parieto-occipital sulcus. Occipital sulcus. So we have parieto-occipital sulcus, which is not as prominent as the other two sulci. This one demarcates the parietal lobe of the occipital lobe. Are you clear? That is the demarcating landmarks for the lobes altogether. So you see, on either sides of the cerebral hemispheres, there are important areas. And these areas, they have 2 or 3 major important functions in our own body. Whatever we do in our own daily activities, they must come. Whatever we will do or we plan to do, they must come to this cerebral hemispheres. All the things that we do, our own activity, they must be either motor activities or maybe emotional activities or sensory, function. So there are motor functions from this, emanating from this hemispheres. There are sensory functions coming to this cerebral hemispheres, and there are emotional functions and other functions related to this. So each of this lobe has its own peculiar functions. For example, now if you take the occipital lobe, it's mainly for vision. It's what? It's mainly for vision. That means as soon as impulses or stimuli from our external environment enters into our eyes, this information is taken through our optic nerve that we said yesterday. And the optic nerve has connection with this occipital lobe. And so as soon as that information reaches the occipital lobe will process, it will receive the information first, analyze it, process it, and then make an integration of what has been brought into that site. The temporal lobe, on the other hand, is mainly for audition. When you hear this word audition, we are talking about hearing. Audition, that means hearing. The other one is vision, visual stimuli or visual stimulus. This one is auditory stimulus. Auditory stimulus. So that means hearing the voice I'm just producing now, the sound I'm producing now is an auditory stimulus which goes into your ears, and then you are able to receive the information through your temporal lobe. Temporal lobe, after receiving, the area responsible for the hearing, will receive the sound, analyze the sound, and then process it. And then you make a meaning of what you have heard. Are you clear? That is the main function of the temporal lobe. Apart from that, just part of the function of the temporal lobe is what we call language comprehension. That means, for example, now, I'm just speaking English. If I speak another language, if it's not your language, will you understand? You will not. But if I say, Edide, who is a Yoruba person among you here? Edide, Dide. See, they have stood up. You get it? So that means they comprehend what I said. If there is a Fulani person here, I say, Ummu. Are you clear? See him, he has stood up. They have stood up. You get it? So all these are what we call language comprehension. Part of the function of the temporal lobe is this. Apart from hearing, then understanding what is said is also the function of that temporal lobe. The frontal lobe has a multitude of functions, mainly motor functions. All the movements that we do in life, sitting down, lying down, standing up, boxing, running, jumping, exercising, flexion, extension, adduction, abduction, lateral rotation, medial rotation, all the stuff. That is the function, all these motor activities or motor functions with regard to the frontal lobe. Apart from that, the most frontal aspect of the frontal lobe, did you hear my word? The most frontal part of the frontal lobe is responsible, one, for cognitive function. I say it's responsible for what? Cognitive function. It's responsible for making judgment, to judge between the wrong and right. If I tell you that coming late to lectures, is it wrong or right? It's wrong. So you are able to judge that. It's no good for one to come because your frontal lobe is okay. Yes. Otherwise, you will never bother. You can come at any given time to lectures. No problem. It means there is a problem there. Are you clear? Your ability to make some memory of what you have heard, what you have seen, what you have eaten, what you have read, all the kind of the stuff. So memory is also part of the function of the frontal lobe. Are you clear? So apart from that, some emotions. Although actually there is a specific area in the cerebral hemisphere where is mainly responsible for emotions, the limbic system, which we'll discuss later on. Are you clear? So even to make some, apart from judgment, emotion, memory, and maybe thinking, for you to be able to think of what to do, like say you think of going home. So for you to be able to think that way is also the function of the frontal lobe. Similarly, planning of what to do. When you think of doing something, you must plan. You get it? Like if you think of going home tomorrow, I think you need to get some money. That is part of the planning. You need maybe to get your cloth washed because you want to go home so that they see you neat. And then you must also plan and get money, how you want to travel, because you cannot go without having money. So you are planning what you intend doing before going. So all these are the functions of making decision to decide whether to go or not to go. For example, now you think of going, you planned of going, but now you decided not to go because of certain reasons. So again, reasoning is also part of the function of the frontal lobe. So you reason that you are no longer going. After all, you have already thought of going. You planned to go, but now you decided not to go because of certain reasons. So all these are the function of, so that means thinking, planning, reasoning, and decision. All these are the functions, making judgment. You get it? Memory. All these are functions of this frontal lobe. We will discuss them bit by bit for you to be able to understand. Apart from that, the parietal lobe is mainly sensory function. So all the sensation except one, all the kind of sensations except one, that is smell, is one that doesn't reach the parietal lobe. So anything that you can think of, probably maybe pain, temperature, vibration, whatever, all they must come towards the parietal lobe, and the information, the sensory information is going to be processed and analyzed, received, analyzed, processed, and then integration of the information. That is the way the information is being, is being processed in each of the lobes that I've made mention. So we have now seen the major functions of the four lobes. When we look at the medial side or the medial surface of the cerebral hemisphere, actually the most important things that one can talk about when you look at the medial side of the cerebral hemisphere is one very long gyros, what we call cingulate gyros. This cingulate gyros is a very curved, long gyros that is lying on the medial side of medial surface of the cerebral hemisphere, together with one gyros, hippocampal gyros. Together, that hippocampal gyros is on the temporal lobe. The two together, they form what you call limbic lobe. Limbic what? Limbic lobe. And that limbic lobe is additional lobes for the four lobes we have made mention. Although conventionally, we have four lobes. But this certain anatomists consider this to be another lobe. But actually speaking, it is not a lobe. It is just a gyros linking with another gyros. You get it to form this kind of connection and what have you. And so we have this limbic lobe responsible for emotion, sexual behavior, and any other type of behavior. Are you clear? So sexual behavior is something to do with limbic system, cingulate gyros and the hippocampal gyros. So the two together, we will discuss the connection very well, together with another structure which we'll discuss again. And so on the medial side, we can see cingulate gyros, and then we can also see prominently the connection between the two hemispheres, that is the cut end of the corpus callosum, because in the midline here, when you cut off the skull cap, you remove it up, you are going to see that the two cerebral hemispheres, they are demarcated by one longitudinal fissure. So there is a space in between left and the right cerebral hemispheres, and in between them, here is what we call longitudinal fissure. So, and you have to pass through the longitudinal fissure before you cut across the corpus callosum. That longitudinal fissure is another fissure with regard to this that we have discussed before. So we now know that there is a longitudinal fissure that demarcates the left and the right cerebral hemispheres. So the cut end of the corpus callosum can be seen when you now look at the medial side of the cerebral hemisphere. And then below the corpus callosum, you are going to see a space just below it. And that space is what we call the third ventricle. We'll discuss the spaces within the cerebral hemisphere. So third ventricle is just the space below the corpus callosum, and I said we are going to discuss that well later. And so below that, in that area, in the third ventricle, you have a bulging, a protrusion in that space. And that protrusion is for one nucleus from within the white matter of that cerebral hemisphere bulging into this space, and that is the bulging of the thalamus. You get it? And so the thalamus of one side here is connected with another thalamus of the other side by what we call interthalamic adhesion. Interthalamic adhesion. So this interthalamic adhesion connects the thalamus of one side with the thalamus of the other side. So this interthalamic adhesion passes through that third ventricle, which we'll discuss later on. So again, when you come down, just on the front here, you have the hypothalamus, the nuclei there, and below here you have your brainstem. And when you go down now, if you cut through and through the entire brain and the spinal cord, so you see the spinal cord. So that is mainly what you are going to see on the medial side. When you look at the inferior surface of the cerebral hemisphere, the inferior aspect of the frontal lobe is far, far different from the inferior surface of the temporal lobe and that of the occipital lobe. So you can see the inferior surfaces of the frontal lobe on either side. Each one of these lies in the anterior cranial fossa. So this is what we call, because this anterior cranial fossa relates to the orbit. When we talk about the orbit, we're talking about the cavity of the eye, where our eyes are lodged. So this roof, this anterior cranial fossa, the bone that forms the floor of this anterior cranial fossa forms the roof of orbit, our eye socket. And so because this inferior surface of the frontal lobe is associated with this anterior cranial fossa, this surface is called orbital surface of the frontal lobe. Are you clear? And this inferior surface of the frontal lobe and that of the occipital lobe, they relate to both the middle and the posterior cranial fossa, where it is covered by tentorial cerebri. So this tentorium cerebri, this, because it relates to that, this surface is called tentorial surface. So we have orbital surface, and tentorial surface. And so that is why in some textbooks, instead of having 3 surfaces, they may tell you that obviously the cerebral hemisphere has 4 surfaces. Reason because the inferior surface is further subdivided into 2 surfaces. Orbital surface related to the inferior surface of the frontal lobe, and tentorial surface that is related to the temporal, inferior surface of the temporal lobe and that of the occipital. So we have tentorial surface and orbital surface. And again, there are sulci that demarcates each of these inferior surfaces of either of these lobes. On the orbital surface of the orbital surface of the frontal lobe, there is a figure H-shaped sulcus dividing the inferior surface of the frontal lobe into anterior frontal part, lateral frontal part, posterior frontal part, and medial. Are you clear? Is there anybody that doesn't understand? This is just the anterior side, and this is the posterior side. I drew it, this is the inferior surface. So these are all in forms of bombs, and so they are called gyri. So we have anterior frontal gyros, medial frontal gyros, inferior medial, anterior inferior, infralateral frontal gyros, and posterior infrafrontal gyros. So now we've seen that we have 4 gyri: anterior, lateral, medial, and posterior frontal gyri on the inferior surface of the frontal lobe. Are you clear? Good. Similarly, on the inferior surface of the temporal lobe, there are 2 sulci that also demarcates or divides the inferior surface of the temporal lobe into 3 gyri. We have the medial, middle, and lateral temporal gyri by collateral sulci. You get my point? These 2 sulci are called collateral sulci, medial and lateral. In some textbooks, we call them occipitotemporal because it begins from the occipital bone or occipital lobe down to the temporal. So it is called occipitotemporal, lateral occipitotemporal sulcus, and medial occipitotemporal sulcus. You get my point? So you have medial, middle, and lateral temporal gyri. Are you clear? Good. So on the superolateral surface, similarly the superolateral surface of the frontal lobe is also divided into 3 gyri. We have superior frontal gyros, we have middle frontal gyros, and then we have inferior frontal gyros. So it means that we have sulci, 1 superior, and then we have inferior frontal sulcus. So we have superior frontal sulcus, we have inferior frontal sulcus. These 2 sulci, they divide the superior lateral surface of the frontal lobe into superior frontal gyros, middle frontal gyros, and inferior frontal gyros. Similarly, the temporal lobe is also demarcated into 3 gyri. We have superior temporal gyros or gyros, we have middle temporal gyros, and then we have inferior temporal gyros. This is also formed by 2 sulci, superior temporal sulcus and inferior temporal sulcus. Are you clear? Good. While in the parietal lobe, there is only 1 prominent sulcus that demarcates the parietal lobe into upper and lower, what we call intraparietal sulcus. And that one demarcates or divides the parietal lobe into upper and lower part. Are you clear? Good. While the occipital lobe is rather undivided. You get my point? So we are all clear about this? Well, thank you very much. I think we are going to have a break.